peculiar episode in the history of physics, namely the Inquisition's attitude several hundred years ago to the idea that the Earth goes around the Sun instead of the Sun going around the Earth. They wanted to promote a compromise with Galileo where they would admit that the positions of the stars and planets and Sun in the sky are exactly as predicted by that theory, but that it was presumptuous of humans to purport to be able to describe the underlying reality, why the stars appeared in one place rather than another. Same thing happened with quantum mechanics in the 20th century. A group of people who didn't like the implications of the theory about reality realized that you could use it in practice by just using its predictions. Now that is a move you can always make with any scientific theory. You can always deny that it describes reality. You can't be proved wrong by experiment, but as a philosophical position, it's a dead end. It's sterile.
I think it's fair to say that most physicists use quantum mechanics to describe the subatomic world without worrying too much about the interpretation. Personally, I'm not in favour of this view. I don't have a preferred interpretation, but I do believe that nature must behave in a particular way. So only one of the interpretations can be correct. And to be quite honest, we probably haven't found the final answer yet, but I think it's only a matter of time. I certainly don't subscribe to the shut up and calculate interpretation. I prefer the shut up while you calculate view. This means I'm happy to do my calculations to study atoms, but when I'm away from my work, I still worry about what it all means. In the last 100 years, we have peered deep inside the atom, the basic building block of the universe. And inside this tiny object, we have found a strange new world, governed by exotic laws that at times seem to defy reason. Atoms present us with dizzying contradictions. They can behave both as particles or waves. They appear to be in more than one place at the same time. They force us to rethink what we mean by past and future, by cause and effect. And they tell us strange things about where the universe came from and where it's going. Pretty amazing stuff for something that's just a millionth of a millimetre across. That's why Niels Bohr, the father of atomic physics, once said that when it comes to atoms, language can only be used as poetry. What's fascinating to me is that although we've learnt an incredible amount about atoms and their behaviour, our scientific journey has only just begun. Because although we know how a single atom, or just a few atoms, behave, the way trillions of them come together in concert to create the world around us is still largely a mystery. To give you one dramatic example, the atoms that make up my body are identical to the atoms in the rocks, the trees, the air, even the stars. And yet they come together to create a conscious being who can ask the question, what is an atom? Explaining all that is surely the next great challenge in science.